Unit 12, Surface Chemistry, Blueprint, Part 1, 2 1 mark question, Part 2, 1 3 mark question, 43. That is the 43rd question from your text, from the exam paper will be asked from this chapter, Surface Chemistry. Then Part 3 has no questions. No question will be asked from this chapter. Part 4, 1 5 mark question, 66B, question number 66B. Any of the public paper, 43rd question and 66B will be asked from this chapter, Surface Chemistry. Now let's see some important concepts in surface chemistry. The very first one, what has to be dealt is adsorption. Adsorption and absorption. There is a difference between two words. One is adsorption. Adsorption, AD, means happening over the surface. When the molecules accumulated over the surface, it is called adsorption. More or less, it is nothing but sticking. Suppose you are sticking one paper over the another paper, it is called as adsorption. Since it is taken place over the surface, it is dealing with the accumulation of gases over the metals, for example, nickel. Hydrogen iodide, Hi, can decompose to form hydrogen and iodine over the nickel surface. This is a very good example for adsorption. Another one is called absorption. Look at the difference between these two. The very first one, adsorption, is surface phenomena, as I have told you. It is absorption, AB. Absorption means all the molecule may enter into that. For example, sponge is there. If you throw the sponge into the water, all the water molecule will enter into the sponge. It is absorption. As I have told you, sticking of gases or accumulation of gases over the surface is called adsorption. Adsorption. There are two kinds of adsorption. One is called physical adsorption and another one is called chemical adsorption. Physical adsorption and another one is called chemical adsorption. So, two different concepts. One is chemical adsorption and another one is physical adsorption. The physical adsorption is entirely due to van der Waals force. Any force which has been applied by applying pressure is called as van der Waals force. Then, chemical adsorption is due to the formation of chemical bond, especially covalent bond. This one, physical adsorption, depends on nature of gas. You can classify gas into two types, lighter gas, heavier gas. For example, hydrogen, nitrogen are smaller gases, lighter gases. Ammonia, carbon dioxide, carbon monoxide are heavier gases. Heavier gases may not move faster, they move slowly. When they are moving very slowly, you can easily bring the larger molecule near to each other. When the larger molecule are bringing near to each other, it can be easily converted into liquid. So, we can classify the gas into easily liquefied form, non-easily liquefied form. Heavier gases can be easily liquefied. In the case of physical adsorption, easily liquefied gases are adsorbed easily. But chemical adsorption is specific. It is specific for a particular chemical. It differs for a chemical. In this case, some heat will be absorbed. Of course, in both the cases, heat is liquid. It is called heat of adsorption. In the case of physical adsorption, the heat of adsorption is very less, very small. But in chemical adsorption, heat of absorption is very large. The physical adsorption is reversible. That is, reactant forms product. At the same time, product gives reactant. But in chemical adsorption, it is irreversible. You can't get back the product. You can get the product from reactant, but no reactant could have been obtained from product. Irreversible. Here, at low temperature, it decreases with the increase in temperature. When temperature increases, the physical adsorption decreases. That is inversely proportional with the temperature. Physical adsorption is inversely proportional to the temperature. Chemical adsorption directly proportional to the temperature. When temperature increases, chemical adsorption also increases. Now let's discuss about pressure. Increase of pressure increases physical adsorption. But here pressure has no effect. That is, change of pressure has no effect. Here in physical adsorption, multimolecular layers can be formed. More layers could have been formed. But in chemical adsorption, only one layer is formed. This difference between physical adsorption and chemical adsorption is a very important 5-mark question. Factors affecting adsorption. Upon what are all the factors it affects? Factors affecting adsorption. What are all the factors affect? One, as I have told you, temperature. Temperature plays very important role in adsorption. Magnitude of adsorption increases with a decrease in temperature. It has been given by Le-Chatelet principle. Then pressure. Then nature of gas. As I have told you, heavy gases, easily liquefiable gases, can be easily adsorbed over the surface when comparing with the lighter gases. Nature of adsorbent. Nature of adsorbent. Any surface upon which it absorbs is called absorbent. So it's a very good example for nature of absorbent. Then we have seen physical adsorption, chemical adsorption, factors affecting adsorption. Now let's see catalysis. What the catalyst is doing? What is the role of catalyst? Suppose water formation, very simple reaction. What you have learned, what you are learning from 6th standard itself. When hydrogen combined with oxygen, water is formed. H2 plus O2 gives H2O. While writing, it is very easy, but practically it's very difficult. Hydrogen cannot readily combine with oxygen to form water. Suppose you are combining hydrogen cylinder with oxygen cylinder, you are getting very small drop of water after a very long time. But if you introduce a burning platinum in that mixture, the reaction proceeded with a very high speed. So a catalyst increases the speed. Here you have to remember that not only catalyst increases the speed, it decreases the speed also. So while defining catalyst, they are very careful. It is a chemical which alters the speed of the reaction. So we can classify catalyst into two types, which increases the rate, and another one is which decreases the rate. Any catalyst which increases the rate is called positive catalyst. Any catalyst which decreases the rate is called negative catalyst. Understood the idea? What is physical positive catalyst? Which increases the speed of the reaction. What is the negative catalyst? Which decreases the speed of the reaction. Now, look at this one. SO2 combines with O2 to form SO3. All are in gaseous state. All are in gaseous state. For this reaction, catalyst has been used. Nitric oxide. So, sulfur dioxide is a gas, oxygen is a gas. These two combine to form SO3, which is also a gas. The catalyst NO is also a gas. If catalyst also is in the same state when comparing with the reactant and product, it is called homogeneous catalyst. So, it is called homogeneous catalyst. Homogeneous catalyst. In the case of homogeneous catalyst, catalyst is also in the same state of reactant and product. Then it is called homogeneous catalyst. Not only in need of all must be in gaseous state. Even this may be in liquid state also. For example, this one. This is one ester. Methyl acetate. It is called methyl acetate. It's a liquid. When it is treated with water, of course it is also in liquid, you are getting acetic acid and methyl alcohol. For this reaction, HCl also in liquid. In the first case, all are in gaseous state, including catalyst. In second case, all are in liquid, including catalyst. So, what I have told you, when the catalyst is also in the same state of reactant and product, then it is called homogeneous catalyst. Understood the concept? Then the next is called heterogeneous catalyst. If catalyst is in the different state, let's consider the same reaction. The same reaction, that is formation of SO3, 2SO3, could have been proceeded in the presence of platinum, which is in solid state. It is called heterogeneous catalyst. In a heterogeneous catalyst, catalyst is in the different state of reactant and product. Same reaction, SO3 formation.